Now that we've talked a bit about limits, let's look at a few more of these limits to infinity. So, for example, the limit as x goes to infinity of x, as you might expect, is infinity, right? Limit as x goes to minus infinity of x, of course, is minus infinity, right? These are the things you would probably expect to happen. Let's look at limit as x goes to infinity of x to the n, right? Now, if we're going to positive infinity, then no matter what, this is infinity. Here I want to specify that n is a positive integer. So these are things like 1, 2, 3, 4, 5, and so on. Right? Now, on the other hand, what if we look at the limit as x goes to negative infinity for that same thing? Okay, so x is a positive integer again. Well, this is going to be one of two things. This will be infinity if n is even. Okay, because a negative number raised to an even power is positive. Or minus infinity if n is odd. Okay? Cool. So, now that we have that, I want to look at sort of the related to the example we did earlier. Right? And again, here, n is still going to be a positive integer. The limit as x goes to infinity of 1 over x to the n, this is 0. Okay? And so is the limit as we go to negative infinity, 1 over x to the n. This is also 0. Oops, forgot the negative. Right, so whether we go to positive or negative infinity, if we have 1 over x to the n, and again, in all of these examples here, n is a positive integer. Right? But if it's 1 over x to the n and we go to positive or negative infinity, this limit is 0. All right, so what does that help us do? Well, it helps us compute limits to, when we go to infinity or minus infinity. Knowing this information, we can figure out certain things. So let's start by looking at a function like this. Or let's do an example here. So we'll say limit as x goes to infinity of x plus x cubed plus x to the fifth over 1 minus x squared plus x to the fourth. Right, let's look at something like this. A little bit more complicated, right? So how do we do this? Well, we want to try to use these properties here, right? Specifically this set. This is the sort of important set for us. Okay? We want to try and use this. So, what can we do? Well, what we're going to do for this is we're going to look at the denominator of this function, right? And look at the highest power in the denominator. In this case, it's x to the fourth. Right? So what we're going to do then is multiply the top and the bottom by 1 over x to the fourth. Right? So again, we look at the denominator, we pick the highest power down here, and multiply the top and the bottom by 1 over x to that power. So why are we doing that? Well, let's look at what happens. All right, so we're going to get 1 over x cubed plus 1 over x plus x on top, and 1 over x to the fourth minus 1 over x squared plus 1 on the bottom. And look what this does for us. This sort of lets us know here, these four numbers right here, when we take this limit, all of these are going to 0. Right? Up here, we can't really separate this out because this is like infinity plus infinity plus infinity. So the top's clearly going to infinity, right? But the bottom, we have 1 minus infinity plus infinity. So what is that infinity, negative infinity plus infinity doing down here? We don't actually have a good way to, at least that we have at the moment, we don't have a way to deal with that. So we want to try and switch it around to where there's at most 1 infinity on the top or bottom, if possible. And by taking the highest power in the denominator, what we do is we ensure that there's no infinities in the bottom, basically. All right? Any infinities that'll happen will show up top, which is great. So now we can do this limit. Right? So again, all 4 of these are going to turn into zeros when we do the limit to infinity. So we're going to get 0 plus 0. Right? And here we'll have 0 minus 0 plus 1. And this x, remember we said that's going to go to infinity. So this whole limit is just infinity. Right? And there we go. So hopefully that helps make sense. You'll apply the same idea to other problems going forward. A neat little summary of these kinds of limits here to give you an idea of what might be going on. If the degree on top is higher than the on bottom, you should expect plus or minus infinity. If the degree on bottom is higher than on the top, you should expect a 0. If the degree on the top and the bottom are the same, then we get some interesting things. And we'll see an example of that in the next and last video on this topic here.